Hello everyone, welcome to the channel. Time flies. It's already 2025 and Happy New Year. And I will start a new video series. I call it All Hail to the AIsm. And the reason I'm started this one because when I learned the AI theory and the algorithm as a hobby, I noticed one thing. So many smart people want want to teach the dumbest person, which is computer in the world, to be a human. And we, as a human, could learn a lot of stuff from this AI's theorem and the algorithm also. That's my driver. And this will be my first try. And I will start from the Bayes theorem and just try to see what can we learn from Bayes theorem to be a wise decision maker and give us some direction how to make a decision to our life. And the best way to learn all the theory after left the university, I found out is YouTube. There's a lot of good YouTubers have very good explanation of a lot of theorem. And I will list a few I learned, try to have a better understanding of theorem, and for example, through blue, one brown, and verticism, and so on. And this will be my new formula. I will use the Excel spreadsheet because I was trained electrical engineering. I have PhD in electrical engineering and mainly in statistics and economics. So usually what we do is we start something with a literature review, introduction, and then we do a methodology and a numerical test. And we give the results and future work recommendations. So basically, this will be the three part of the spreadsheet. So let's start with the introduction of the Bayes theorem. I think a lot of people know Bayes theorem from that paradox medical experiment, and I'm the same. Actually, I learned it from a statistical midterm, and the professor gave two Bayes theorem problem at the end as two big problem. I have no idea how to solve it. I was wired to hell, and fortunately, or unfortunately, everybody did it as bad as me, and the professor decided to just use those two as a option, no problem. Yeah, and the lesson learned that gave me a big impact. So I always remember the Bayes theorem and I always try to have a good understanding. So here I am, and try to explain to you and explain to myself, and try to see if how can it help it to our life. So I'll start from notation first. So basically, and it will be a hypothesis, it's a normal statistic term, and for example, certain disease in a population, and also there's an experiment to test the disease. And we have a probability of the people have the disease in this population. We call it prior probability. Of course, we have a prior false probability, which means the people who don't have the disease. Then we have the probability of the experiment, basically the test positive probability in this whole population. And meanwhile, we have a few condition. No probability one is if you have the disease, what's the possibility the test will show a positive? So we call it true test positive possibility. Of course, we'll have another term called false test positivity probability. The last one will be given the test shows positive, what's the possibility you have the disease? We call it the post probability. So the so for the Bayes problem, we start from a prior probability, P of H. Then after the experiment, we reach a probability called P of H given E, which we call the post probability. This will be the formula of the Bayes theorem. It will have a very easy way to use a condition probability to prove this. And the formula here basically it means it's this a prior probability and it's a post probability. And the relationship between the two will be a factor. You just multiply a factor to the prior probability, you will update your belief or probability to get the post probability. And the idea, the most important, one of the most idea of the Bayes theorem is it actually a little bit different with the traditional statistics. It will give you a way and methodology to update your probability. And then, and the way to calculate actually, if you, I when I learned this, I just try to remember the formula. That when after I watched YouTube, for example, 3 blue 1 brown, he has a good square to explain this thing. So basically, the whole square is the whole population. This side, a blue color, is the people who has a disease, and this side is who people who doesn't have this. Of course, you can think all the sides is just one. The whole area will be one. And then this little square is the people who had the disease test by this experiment positive. And this part will be people who doesn't have the disease test positive. And this will be the prior probability. And how to calculate the post probability is very easy, right? This experiment limit your sample size to this guy instead of the whole sum. So the whole sum who has a positive test results will be the P of E, which will be the denominator. And also the people who really have the test positive will be the numerator. So that's how you update your probability and belief. And after you understand it, you write it in this form. You will see this will be the update factor of the BS theorem. So this will be very good understanding. It will help you understanding. So if you cannot remember this formula and you will just think about it, put this square in your brain, you will have good understanding of the how to calculate the BS, how to use the BS formula. And also there's another interesting explanation of the BS theorem. It's using odds. It's also from 3 blue 1 brown. One thing I think there's two good information come from the experiment using odds. One is the easy calculation, and the other one will be the explanation of the BS factors. It's very useful. So basically, instead of using prior probability, a prior odds is used. Odds, for example, 1 to 9 odds, you just can easily convert it to a 10% probability. And also the condition of positive have the disease divided by the test positive who doesn't have a disease will be Bayes factor. And in the next part of the video of the numerical experiment, I will explain what does it mean. And also this will be the post odds. The formula is very easy. And you can use the Bayes factor multiplied by the prior odds can easily get the post odds. And you already know it's very easy to convert between the probability and odds. Once you calculate odds, you will get the probability. You can convert between the probability and odds. So just summarize all the introduction of the Bayes theorem. We can see the Bayes theorem explains how the probability odds can be updated by the experiment. It's actually very useful information. It can be used to make a statistics decision, artificial intelligence decision, and even for our personal life decision. Of course, there's an exception for the Bayes theorem. Of course, because there's a denominator here, that basically means the denominator cannot be zero. I give some try to explain the exception here, which will not be the part of the video. If you're interested, just take a look for fun. So now let's come to the middle part of the numerical experiment. Excuse me. So I just basically I will start from the prior probability. What I did is I just start from 0 all the way to 1, and the incremental step will be 1%. Once I notice that Excel actually is not exactly 1%, so that's the reason I force an accident to 1. And also then we'll have the prior false probability. It's basically the 1 minus prior probability. Then we have the true test positive probability will be here. Let me put it back. This would be what I should start it, because when I do a dry run, I change the number. Yeah. So this will be the true test possibility, 90% here. In this case, it will be the false test positive probability would be 5% here. And this will be the test positive probability PE. Pretty much is denominator here. You can use the formula here to calculate the PE. And also, after you have all this information, all these components in this formula, you can easily calculate the post probability. Okay, so that's how I calculate. And also add another information here. I just want to show you what's effectiveness. Basically, it's very simple. Just the post probability divided by the prior probability show the effectiveness of the experiment. And also, I have the odds here. This is the prior odds. You can easily use a formula to convert between odds and the probability. Then I have the post odds. This I calculate the Bayes factor, then use this formula to get the post odds. That's pretty much the numerical part. It's very simple, and I just did this. And the interesting here will be plot a few information here. So the first one I plot here is the prior probability. And this basically is the from start from 0 to 1 with incremental of 1%. It's just the straight line go this way. And also we have the orange line, which is the postal probability calculated using the Bayes formula to see what's the effect of the experiment. Then I add another one line I call it influence path. I mean, you can call it whatever you want. It's basically what does that means. You have a starting prior probability of certain belief. You do one experiment and you updated your belief, and then you do a few more to see how it goes. That's what the purpose of this so-called influence part, or you can call it the update curve or something. So basically, I just want to show you, demonstrate you the effectiveness of the experiment. Now, and will be the interesting part. I will try to use the Bayes theorem and the plot to explain some of the what are Eastern culture, Western culture beliefs or idioms or whatever you call it. And so I will have, yeah, first one to the belief, basically to the prior probability. The other one will be talking about something about the experiment. So I will start from a very simple one. For example, it's called in English called first impressions are everything. In Chinese, we call it 先入为主. Basically means the post probability is uppermost at early stage. You can see from the rate. If you don't believe something, someone suddenly show you an experiment or something, your belief will be update a lot. So the effectiveness of the early influence will be very important. So that's the reason when you start an interview or something, you usually try your best. You did the right thing, try your best to give your panel a good impression and so on. And you can see from here the rate. And the other one is very interesting in English called repeat lies become fact. You know that. I'm sure you know about this saying. And in Chinese, we call it 三人成虎. Actually, in the Chinese, we have historical story. It's very interesting. So basically, there's a wise king. I have to emphasize this. A wise king. He has a favorite general. And the one time he sent his favorite general to conquer a small country. And this general think, okay, I have to spend like 3 or 5 years to finish this military task. But he know once he left, someone will say bad thing about him. He went to approach his king and tell him a story. He said, "My wise king, and I will tell you a story." So basically, if there's one person come to you tell you there's a tiger in the supermarket, are you gonna believe it? Believe it? The king said, "I'm not gonna believe it." He said, there was another person come to you and tell you there was a tiger in the supermarket. The king thought about it a little, said, maybe, I'm not sure. So the general said, there'll be a third person come to you, tell you that there's a tiger in the supermarket. Are you going to believe it? The king think a little, said, I probably will believe it. Then the general said, my dear wise king, if after left, I'm sure some people will say something about me. I hope you trust me and I will finish the task for you. The king, just don't believe them when they say the bad thing about me. So the king promised him, said for the next 3 or 4 years, he's going to ignore any bad story about him. So these two trust each other, then the general finished task. This is a very interesting story. So basically, and you just repeat the lie a few times, it becomes fact. You can see from this curve here, right? It's exactly something. For example, there's a tiger in some supermarket. For example, if someone tell you come back, we can say there's a tiger in Costco. You're probably not going to believe it. Then your sister come back, tell you, and the brother tell you, and your father come back, tell you, oh, you will say, oh, there was a tiger in the supermarket. So basically, it's just saying that repeated lies become fact. And actually, sometimes not even lies. You want other people believe some theory or some news. You just constantly repeatedly tell them they will believe it. I mean, not just limited lies. The truth here. Sometimes people don't know the truth. You have to tell them multiple times. That doesn't believe. So this is explain the philosophy of the repeated lies become facts. 1, 2, 3. I mean, you see this. The belief just increase a lot. So the other one is I call it if you want to persuade yourself. Persuade yourself before you try to persuade others. For example, you have some kind of experiment or something you want to let others believe or something like that. You have to make sure you believe it yourself. I mean, very persuasive. For example, here, basically means at least your biggest fact has to be larger than 1. If it's smaller than 1, there's no way you can persuade others. I mean, for example, I can just change here. I change this to 40. So usually we think the BS update the belief actually increase belief, but actually not. If your BS factor is less than one, it's not going to. It's actually going to do the contrary to damage the belief. So that's what I'm trying to say. If you want to persuade other people, better have a good experiment which can persuade yourself first and apply to others. Yeah. So you can see this curve actually make the post probability worse than the prior. Okay, let me change back to the good ones. So the other thing is very easy to understand. It's called never argue with an idiot. Here probably we don't mean it's a real idiot. It's just talking about people has a solid belief on something. For example, they completely not believe something or completely believe something. So once you can see from this curve, it's not going to change because you have zero, you have the factor, it will be a zero, something like that. So if it has a zero belief on something, so you don't have to waste time to try to persuade them to change their belief and so on. And in a Chinese, it's called 夏虫不可以语病, basically mean there's some bugs they just live in the summer. If you tell them the ice snow, they will never believe it. Basically, that's what I mean. And what we learn, what to ourselves is we should not completely believe something or completely disbelieve something. We should be somewhere in the influence curve middle or the post probability curve middle to give us some opportunity or chance to update our the belief to learn information. And then the other one, this one is a little bit tricky, and it says it always seems impossible until it's done. So basically, if even the belief is very low, but if you have the very good experiment, basically means you'll probably have a very low false. You have very low false test probability. You can change people's belief dramatically. For example, this is 5. I put it to 1. Let me show you what's going to happen to that curve. You can see the you can dramatically update the people's belief if your experiment is good. And if you one extreme situation is will be 0, and you kind of like instantaneously change people's belief because you show something they have to believe. Of course, the reason you cannot change to them to completely believe of you because that perfect experiment probably doesn't exist. So I was just saying, okay, when you say it, we can true, but when I say it always seems impossible until it's done. This means you say it, you have a higher belief. That should be the case. So the last one to the belief, actually there's a lot. I'm just here, I just summarize a few. So listen to the information from different sources. So basically in Chinese it's called 兼听则明, 偏听则明. If you just listen to one source and you don't to listen to, you will just your belief will dark. You don't see the full picture. If you see from listen to everybody and you get all the information, you will have a good view of the problem. And so for us, how to deal with different information will be, to be a wise person, make a wise decision, you should not just listen to one person. If you just listen to one source or one person, probably they are cheaters, you will be cheated. But if you listen to different different news sources, you will form your own opinion, and you can keep getting information to update your belief. So that's the same, listen to the information from different sources. Okay, here we already talked quite a lot about how to update the belief and how to make some wise decision based on the BS theorem. Also the curves. We showed the numerical experiments to show you how to explain these philosophies. And the other one, I think the one I was very interested in, mentioned by one of the YouTubers. We always, when we're talking about the BS theorem, we always just think about the prior probability, post probability of the beliefs. We don't talk about the experiment a lot, but actually the experiment itself has played a big role in this theorem or formula. So basically, for example, I just say in simple, when the experiment does not, we'll change the experiment. So what does that mean? So I already showed you, right? For this experiment, it has a Bayes factor of 18. So it effectively updated your belief. For example, you have certain belief of a good career, good life, better career, better life. but you work hard, you try and you try. It doesn't feel it's going that way, because instead of the post belief or post probability is going this way, it actually going down. Even after you repeated experiment and you hold on, you try and try, your belief to become a better, you get your promotion, your career or better life is, you slowly see the chances decreasing. And what you maybe that's a time to think about the change, the maybe your experiment or your career path or something you need to consider to change about it. For example, from a bias factor less than one, like going down of the belief of the better life or better career, to a good one which has a bias factor of 18, to you can see the effect your belief is, you got positive feedback, your belief of better life, better career is increasing. And of course, when you change the experiment, it's sometimes hard decision. You have to change the consequence. You have to think about the change of the consequence change of the experiment and the cost to change the experiment, and so on. And that's pretty much all of it. And I summarized all the I explained and summarized the how to understand the Bayes theorem, and I have a little simple numerical example, and also I list a bunch of philosophy to the how to update the belief, how to make right decision, and also I have something to talking about the experiment, maybe about it, consider change the experiment if your cost is not too high, the risk is not too high, some so on and so on. So basically, yeah, try to use the Bayes theorem to help us to make wise decision in our life and explain the ancient wisdom. And this will be my first try and of the theory called All Hail to the AIsm. And the reason I named it AIsm because there's so many done, and they basically try to tell you how to live your life and how to make a decision and how to improve your life, some so on. So that's the reason I call it AIsm. This would be my first try, and if you feel interesting and if I have some more update, I hope we can see you in the next video. Bye.